Hello friends, welcome to aimstoday YouTube channel. In this class we are going to say about IIT-JEE NEET Foundation Chemistry Atomic Structure Chapter Part 8. In this part we say about the Bohr's model of atom. In 1913, one of the Rutherford's students, Niels Bohr, proposed a model of atom that was consistent with Rutherford's model and the quantum theory of radiation. He modified the problems and limitations associated with Rutherford's model of atom. Here we see the important postulates from Bohr's model of atom. Electrons revolve around the nucleus with a different energy in concentric circular orbits, which are called as stationary orbits or stationary shells. These orbits are denoted with the symbols K, L, M, N and so on, or 1, 2, 3, 4 and so on. So here this is a nucleus. Around this electrons are revolving in the concentric circles paths, which are called as stationary orbits. The electrons have the least energy in the K shell of an atom, followed by L shell and M shell and so on. So the shell which is nearest to the nucleus having the lowest energy, and next the orbit which is further to the nucleus having higher energy. As long as the electron revolves in the same circular orbit, energy is neither radiated or absorbed by the electron. That means until and unless an electron revolves in the same orbit, its energy will be constant. That is why these orbits are called as stationary orbits. Energy of the electron changes only when it moves from one orbit to another orbit. Energy is absorbed when an electron jumps from an inner orbit to an outer orbit and vice versa. Energy changes during the electron jumps from one orbit to another orbit is given by the equation delta E is equal to E2 minus E1, that is equal to h nu, where here delta E represents the energy difference, where E2 and E1 are the energies of higher orbit and lower orbit respectively, and h is a constant called Planck's constant, and nu is the frequency of the radiation or energy emitted out. Now here we see the defects of Bohr's model of atom. Bohr's theory could not explain the atomic spectra of higher elements such as helium, lithium, beryllium, boron, carbon, etc., which have more than one electron in them. Bohr's model could not explain even hydrogen spectrum obtained using high resolution spectroscopes. That is, each spectral line on high resolution was found to consist of two closely spaced lines. It was observed that in the presence of a magnetic field, each spectral line gets split up into closely spaced lines. This is known as Juman effect. Bohr could not explain this Juman effect. And similarly, these spectral lines are splitting into closely spaced lines in the presence of even electric field also. That is known as Stark effect. Even this Stark effect also could not explained by Niels Bohr. Bohr's theory could not account for the formation of chemical bonds. Here you see the distribution of electrons in orbits. The systematic arrangement of electrons in different shells of an atom is called electronic configuration of that element. For writing the electron configuration of an atom, we should know the following points. One of them is the total number of electrons present in the atom, and then the maximum number of electrons that can be accommodated in each shell of an atom. Bohr and Bury together proposed certain rules for better understanding the electron configurations of the atoms. Let us see those rules here. Out of them, the first one is the maximum number of electrons that can be accommodated in a shell is given by the formula 2n square, where n is the number of the shell. According to this rule or this formula, we can see the maximum number of electrons that can be accommodated in the first shell is given by the equation number 2n square. If we substitute n in the 1 in the place of n, we get 2. This means first shell can accommodate maximum 2 electrons. Similarly, if you calculate the maximum number of electrons that can be accommodated in fourth shell by the formula 2n square, if we substitute 4 in the place of n, we get 32. Means fourth shell maximum it can accommodate 32 electrons. Second point, the outermost shell of any atom cannot have more than 8 electrons, even if it has a capacity of holding more electrons too. That means the outermost shell will be having maximum 8 electrons only, even though its capacity is more than 8. For example, if M shell is the outermost shell of an atom, it can accommodate a maximum of 8 electrons only, although it has a capacity of accommodating maximum 18 electrons. That means M shell nothing but the third shell. Its maximum capacity is actually 18. Even though its maximum capacity is 18, if this M shell is the outermost shell for that element, it will be having maximum 8 electrons only. Next point, an atom becomes stable if its outermost shell has 8 electrons, or if it has only one shell containing 2 electrons. The penultimate shell can accommodate a maximum of 18 electrons. Here the penultimate means last but one shell. Second, that means but second from outermost. Next point, electrons do not enter into a new shell before the inner shell is completely filled. That means after completely filling the inner shells, then only the electrons enters into a new shell. So these are the points regarding the electron configurations of elements. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates.